Bam, there it is. So these are the answers to the first chunk. Danny? No idea. Myers or Chew, I think. Well, I'm recording videos now, so you can't say that kind of thing. Okay, so then I gave you guys, the next chunk I gave you, ladies and gentlemen, the next chunk I gave you was odds, thank you, and the answer key is there. So I'll leave that to you to check. The answer key, you were provided with the answer key, which you would have seen if you flipped over to continue doing 25, 27, 29, 31, 33, and 35. So if you didn't notice the answer key there, it means you didn't flip the page. It means you didn't do all your homework. So I'm just going to keep going. The last chunk here, I wanted you guys to do aces, which were the odd letters. And the odd letters look like this. This one's going to be x minus 2, x plus 9. This one's going to be x minus 7, x minus 5. This one's going to be y minus 7, y plus 2. This one's going to be 10 bracket x bracket bracket bracket. I want them to, it's going to be plus 6 plus 2. I is a tricky little bugger. We're going to pull a negative out, and then we're going to rewrite this thing. D squared minus or plus 5d plus 24, and then this thing's going to become, put a d there, multiply to 24 and add to 5. 8 and, no. But you need to multiply to positive 24 and add to positive 5. So I want to make sure, but I'm pretty sure it's not going to work. Okay, that's as far as we can go. So this one, as far as the techniques go, that's as far as you can factor that one. Okay? With the techniques that I've taught you, this is as far as this one can go. K is going to be looking like this. I'm going to have an X. What do you mean? Yeah, I did. Sorry, you want me to explain again? I factor out the negative. That's the first thing we got to do. You got to factor fully. So I pulled out the GCF, which was -1. And then there are no pairs of numbers that both multiply to positive 24 and add to positive 5. So that's it. I'm done. That's as far as I can currently go. I wrote them in the proper order. Yeah, I wrote them in the right order. So then this one here is going to be -2 and positive 14 in front of those y's there. That's K. M. Ooh, M is tricky. How does M differ from what came before? Technically, it's not a quadratic, but it is factorable using techniques that I've shown you. How did we get x squared? Is there any way to get x to the 4th? Because if I put my x squareds out here, x squared times x squared is going to give me x to the 4th. And then x squared times something plus x squared times something else is going to give me these things that add to x squared in the middle. So the only difference here is that instead of having x here, we have x squared. So then the rest of this is going to go something that looks like this, -10 minus 5. And then O. A few of you were asking me about O. I need two numbers that multiply to -625 and add to 0. No. It's -25 and positive 25. Yeah, so this one, and the reason I give you O is the very last question I assigned to you, because this leads us into what we're going to talk about today. This is, you would never see this thing written like this. How would you see O written properly? Do you ever see minus 0 or plus 0 anywhere? No. So what you'd see is this, x squared minus 625. And then I would tell you to factor something like this. I explicitly had the 0x in there because using the techniques you know, it's obvious. Okay, well, I was hoping it would be obvious. I want them to multiply to the last and add to the middle. The only way I'm going to get something that multiplies to the end and adds to the middle is if it's the same number, same absolute value. One's positive, one's negative. So negative 25 in this case and positive 25. If I presented it to you like this, I was willing to bet that we would, I don't know what to do. But what I wanted you to see was this x term just has a 0 coefficient there. What is special about this? There's only one occasion where this method, what you see here, will work. And that is when? No. It won't work with positives, you're right. Because one of these is going to have to be negative every time, and one of them is going to have to be positive every time. So it has to be subtraction in the middle. The constant term must be negative. And what else must be true of the constant term? It's got to be a perfect square. Which leads us to, flip the page, a special kind of factoring called a difference of squares. Okay? So when you are asked to factor quadratic polynomials, I started with, what was yesterday's lesson called? Factoring simple quadratic trinomials. We're expanding now. We're getting away from just trinomials, and we want to factor quadratics in general. So a special kind of quadratic that we're going to look at here is called a difference of squares. And this one has a technique that will make questions like O very, very easy. If I have something like this, x plus 4 times x minus 4, if I FOIL that thing out, what am I going to get? X squared, sorry, plus 4x minus 4x, minus 16, okay, which means my last step is going to be what? X squared minus 16. When I've got the same number, plus and minus in here, I'll zoom this in a little bit so it's bigger, that middle term is going to go away. Well, why? Because it adds to 0. And when things add to 0, you don't need to include them in your list of terms. So then this thing then now is what's called a difference of squares. It's called a difference because you're subtracting. And it's called of squares because both this guy and this guy are perfect squares. And so there's a technique if you notice a difference of squares, there's a real nice easy technique. You know that in order to get the second term in the binomial, what am I going to have to do to the constant? To go, if I give you this now and go the other way, how is the second term in these binomials related to this thing? It's the square root. And then the square root's positive and negative. So positive and negative. And that's it. If you notice you've got a difference of squares, it's a nice little technique you can jump to. So if I give you something like this, x squared minus 1, is this thing a difference? Am I subtracting? Here? Is x squared a perfect square? Is 1 a perfect square? Yeah, because 1 times 1 is 1. So I just go straight to here. X minus 1, x plus 1, and we're done. You can check it by expanding it if you want, but that's it. Yes, Kyla. Yes, that was where we were going next. B. Is our first term a perfect square? Yeah, what would it be if I square rooted x squared z squared? It's going to be xz or xz, depending if you're Canadian or American. We're going to have a minus, we're going to have a plus. Now, is 225 a perfect square? Is it 15? It is 15. So we're done. Easy. How about C? Someone tell me what C is. Done. The first term's a perfect square, the second term's a perfect square, and we're good. Angel, how about you try D? Yeah, Angel, it's all you. Can you divide 25 by 4? No. Hold on, you tap out because I got a hand over here. Danny.
Would it be 2x plus 5y?
You betcha.
2x minus 5y?
You betcha. Is 4 a perfect square? Yeah. So 4x squared is a perfect square, so we're going to have a 2x and a 2x. And then 25 is 5 and 5, and the y squared is going to give me the y and the y. So it's going to be 2x plus 5y and 2x minus 5y.
What happens if the 4 was like a 5? What would you do?
What, say what?
If the 4 was a 5 instead, you would just divide the 5 instead of 5 and 5.
Yes, if it was 25x squared minus 25y squared, then we would do what Angel wanted to. Is that what you meant?
Oh.
Or if it was 5x squared minus 25y squared. I don't understand your question.
No. Just a number that wouldn't be able to be squared or...
Oh, so Danny's asking this question. What if it was this? What if? Okay, what if I had that? Is that thing a difference of squares? Is this thing a difference of squares? First of all, answer that question. Is 8 a perfect square? Is 25 a perfect square? Well, one of them's not, so it's not a difference of squares. And is there a GCF here? No. So there's nothing I can pull out to make this thing look better. So it's done. It's nothing to do. This is not yet factorable. Because this, the 8, is the problem. It is not a perfect square. Are we cool with why that is?
Yeah, what if it, okay, it wouldn't be a quadratic, but what if it was like 8x cubed?
Well, as soon as you cube something,
And then make everything else.
make it a different of cubes.
Yeah.
Cubic factoring is not something. Okay, so Danny's asking another good question. You're all about these what ifs. There are cubic, so you're asking, like, what if this was a difference of cubes, perfect cubes? Like 8x cubed minus 27y cubed, because 27 is a perfect cube, and 8's a perfect cube. There are techniques for dealing with perfect cubes that I am not touching this year. We might do it next year. I know Myers, it's one of those things that Myers just kind of tosses in there. Typically, cubic factoring is not something we teach in high school because it's not useful. The quadratics show up everywhere. Hold on. Quadratics show up everywhere in life. Physics, engineering, chemistry, biology, shows up everywhere. Cubics, not so much. So we hammer home quadratics, and then we just tell you, okay, guys, it's difficult to talk over all of you. So we hammer home quadratic factoring, and we say there are techniques for such and such thing, other thing, but you'll learn them later if you need them. Because once you learn a particular set, once you have a particular set of knowledge, it's really easy for you to go then on your own and extend it. Where if I asked you just out of the blue, come up with this factoring thing, that's a lot harder to do. But now that you've seen a simpler case, you want to extend it to a more complex case, you're welcome to do that. So I'll show you kind of an example of what I mean here. Some of the things that we've talked about that are not yet factorable are going to be factorable using something that looks like this. Put your hand up if you've ever seen this. No, do not write this down. Do not write this down. Hands up if you've ever seen something looks like this. Carolyn has, okay?
I've seen each individual thing.
A, B, C, something squared multiplied by 2 and x.
That addition and subtraction
Okay.
thing, but I don't know.
So no, my short answer is most of us have not seen this. Okay? This thing is called the quadratic formula. And it is used for factoring anything that looks like this. Doesn't matter what A, B, and C are. This thing gets factored like this.
What does the plus and minus thing mean?
Means there's two answers here. One where you take the addition and one where you take the subtraction.
Oh. Okay.
This is a nice little beautiful formula for factoring a quadratic. Now, because Danny asked the question, I'm going to show you what the formula looks like for a cubic.
Oh. It's going to be a lot.
Yup. It is, in fact, going to be a lot. Okay. Oh, where'd it go? Come back. Cubic, come back. It's taking forever. Okay, so this is one. Here is the next one. Okay. So we're already on page 3. I skipped the first 2 pages of this document. It says the cubic formula. Here are the steps for finding the roots of a cubic polynomial of the form this. You do these steps. Isn't this an example here? No, I don't want a second example. I want, here we go. I want in general, the general cubic. Oh, that's not even the general cubic. I waited all that time for nothing. Yeah, there it is. This. This is one long equation. It says the x equals the cube root of b cubed divided by 27a squared plus bc over 6a squared minus d over 2a plus the square, and then it continues plus this square or this cube root, then this minus this, and there's a square root inside there, minus b over 3a. This is the cubic. It's awful. Okay? This is the quadratic. It's nice and easy. There are no cases. This is the cubic. You're not. I have a master's degree in mathematics, and I have never once used that equation. Because the point is, and it comes back to what I said before, we teach you guys a small set. Here is all the techniques for quadratic factoring. So that when you see, once I teach you how to use this thing, you just recognize, oh, I just plug my B's and A's and C's in here, and it gives me X, and I then have a set of steps that I use once I have found my values for X, and it's nice and easy. I mean, you could do this. I just take A, B, C, and D, and I shove it in here, and I grind it out. You could do this. How many of you want to do this? No, you don't. And so why would we don't teach this because it's just an extension of this. This is easy, and a computer can do this. So that is why, as soon as Danny asked, but what if it was a perfect cube? We don't want to answer that question because it's awful.
Yeah.
For a whole host of reasons. So, back to this. Example E. Someone would like to be brave and factor Amina. Hand was first.
X to the 4 plus 1, x to the 4 minus 1.
X to the 4 plus 1, x to the 4 minus 1. And now my question to you, Amanat, is the instructions were to factor completely. Are you done?
No.
Do you know why you're not done? Because Tanmeet does.
No, I don't.
Tanmeet, take us away. Well, what she's done so far is correct. My question is she done?
No.
Why isn't she done?
Because x is not a square.
That's not why.
You want the variable not to have a square?
Nope. X to the 8 is a perfect square. It's x to the 4 times x to the 4.
Right. Well, that can further be simplified.
What can further be simplified or factored?
X to the x squared.
No, what here can be factored further? Specifically, x to the 4 minus 1 can be factored further. Because is this a perfect square? Is this a perfect square? And is there a difference? Yes. So this piece can be factored further while this piece cannot. So Amanat, first step was beautiful. But then you stopped too soon. So now x to the 4 rather plus 1 stays where it is. What's this thing going to get broken up into, Amanat? Or Tanmeet. She can hand it off.
Okay. X squared minus 1.
Right? X to the 4 minus 1 is a difference of squares. So it's going to be x squared minus 1, x squared plus 1. Hold on. I know what the question is, and I think pretty sure the answer is yes. Hold on. Are we cool with what's happened here?
No. I get it once you distribute it, but
Okay? Because x to the 4 is a perfect square. It's x squared times x squared. And 1 is a perfect square. It's 1 times 1. So we can factor it by writing it as x squared minus 1, x squared plus 1.
oh.
And the x to the 4th plus 1 that we had before, it comes along for the ride.
So nice.
Acom, am I done? Yes. Pretty sure you were going to ask another question.
No. Yes, you don't. I think no, you're not done.
What were you going to ask before?
Oh, I was gonna ask if you can do plus one and like I did plus one on that side and
Oh, it doesn't matter. Carolyn, am I done? No. Because this piece right here is still a difference of squares. So we keep going. And now we're finished. That one broke up like that. This one broke up like this. Take a look at that until you can sufficiently convince yourself that everything we've done was correct. I'm gonna.
Would you do the same thing for us?
We're not looking at F yet. Are we cool with E?
Yeah. Kind of.
Okay, we got some no's. Okay? What part of E is making us uncomfortable? Why are there 4 of them? Okay. Hold on. Because a factor. I can't hear. Harwin. Sorry, Harwin?
Why are we adding another set of
Because we want to make sure to factor completely, the instructions factor completely means break this thing up as far as you can into all of the bits that multiply together to give me what we started with. So the first thing we did is we broke it up. We said this is a difference of squares, so I broke it up into x to the 4 plus 1, x to the 4 minus 1. Pretty cool with that. Okay? So now we look at each of those pieces. Say, okay, this is done. I can't do anything with it, but what's this guy doing? Is he a perfect square? Or it? Is it a perfect square? It is. You see why it is? So the difference of squares. So I can break this guy up further into x squared minus 1 and x squared plus 1. And this piece that just gets multiplied along here, it comes down to the right. So now my factored version of this is x to the 4 plus 1 times x squared minus 1 times x squared plus 1. Are you cool with that? Okay, now we have to check each piece again. He was good. He was good. She is a problem. I don't know. Because I figured having a class of mostly girls, I'd get a reaction. Why is she the problem? Because she is a difference of squares.
So why is she a problem and not he?
Because I just picked it arbitrarily. Because I knew I was going to get a reaction from a class of 75% girls.
Yeah.
And sometimes it's fun to push your buttons on a Thursday afternoon. So, x to the 4 plus 1 stays. X squared plus 1 stays. But this difference of squares gets broken up into x minus 1 and x plus 1, and now we're good. As long as a difference of squares. The of squares piece is important. X is not a perfect square. So now I know I'm done. Even though there's still a difference here, hey, it's not a difference of squares, and so you need the difference. These ones, stop it. This one is not a difference, which is why it doesn't go any further. Even though these are all perfect squares, you need to have that difference. This one is a difference, but that's also, it's not a perfect square anymore, so we're done. Now each one of these has been factored as far as it can be factored, and we are done.
But what if it wasn't?
No, stop. But what if? No, it doesn't matter. We're done. No, stop. We're done. Next one. Okay, so was it Amanat or was it 10 meet or was it Angel? One of the three of you said. But what about F? So let's look at F. What is the first step to factoring F? Carolyn. Okay, now we look. Are we done? No. Carry on. Harwin. Careful. It would be 4. Correct. Is she done?
I want to say yes, but then I'm also like, if that Q was squared with a -4, then she would be done.
But it is, because it's, you do that a lot. But if this was true, yeah, but it's not. So we're not. Are we done? Yes. Flip the page. Let's make our life more interesting. Yes.
Why do we, like, is this something we'll actually use in life?
Believe it or not, no. You said in life. Am I ever going to be using this in life? That's not why. If all I cared about was if all you cared about was learning math that you needed to learn in real life, none of you would be here.
No.
That is not the purpose
Unless we're math.
of a pre-calculus or honors math class. If you wanted to learn if all you wanted to do was learn the math that you were going to do in regular life, y'all should have just taken A&W and called it good. But you didn't. A&W is apprenticeship and workplace math, which isn't offered to grade 9s. It's offered to grade 10s and up. If all you want to learn is my practical everyday math for life, that's the course you take. But I know, but I get passionate about this because students ask me all the time, when am I ever going to use this? Never. That's not the point. The point is, what I'm doing here is I'm teaching you a whole bunch, like, when are the vast majority of you ever going to learn how to use when are the vast majority of you ever going to use a jackhammer in your everyday life? You're probably not. But if you had the opportunity to learn how to use one, would you want to learn how to use a jackhammer?
Yeah. Well, no. Maybe. It's too loud.
Some of you maybe, some of you maybe not. But if you knew you were going to go into concrete work, would you want to learn how to use the jackhammer?
Yeah.
Yeah? whatever. Okay. I feel like, because some of you are going to go off in, like, you're going to take upper level physics courses, you're going to take upper level, you're going to engineering. These are all techniques that you're going to use ridiculously there. Chemistry, maybe. There's some fringe chemistry work that this shows up in. Any course, any program you might be interested in taking that requires you, ladies at the back, to take calculus, you will need to have these skills. But for the rest of you, this is just building your brain. It's none of you are ever going to play badminton professionally, and yet we teach you how to play in PE because it's good for your body. This is good for your brain. You are not going to be a professional badminton player. I would have heard of you already. Carry on. Let's go. You know what? You might be. Prove me wrong. I would love to watch you, a professional badminton player. Prove me wrong. Okay, G, Carolyn. Yes, the GCF is 5, so let's pull it out. What am I going to be left with? Cool. Perfect, love it. We are finished because 5 is not a perfect square. Everything she did there was absolutely correct. Yes, Ria. You betcha. Okay, H, here we go. Yes, Harwin. What are you talking about? Oh, like if this had been, oh shoot, like if this had been, yeah, if this had ended up being 20, we could have done, yeah, the short answer is yes. Yes, we could, yes. Because 5 is not a perfect square. Sorry? Is that why I reduce? Okay, guys. If this, so if you're asking the question you're asking, so let me work it backwards. Don't look. X to the 4 minus 4 to the 4. Just talk now talk amongst yourselves. Now don't be quiet. Okay, now stop talking again. I'm back. You wasted your time. Here we go. If the question was this. What would we do? Harwin. Not yet. Don't skip this middle step. What are you doing with the 5? 5 is a GCF here. You can't jump straight to doing this until you've factored out the GCF. So it's going to be 5, and I'm still going to have the x to the 8. What's 80 divided by 5? 16. Oh, that should be an 8 as well. Okay. So now what would my next step be? I'm going to...
And then the same thing with a minus sign. Yeah.
Am I done?
No.
Now I'm not, because 4 is still a perfect square. So this would stay the same. X to the 4 plus 4, y to the 4. And now this would get broken up. Bracket, 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 bracket. Into what? Am I done? Careful, careful. 2 is not a perfect square. No, we're done. 2 is not a perfect square. It's 1 plus 1, not 1 times 1. 2 is not a perfect square. Carolyn, are we ready to go on to H? Are we cool with this? Okay, here we go, Carolyn. H, take it away. GCF, yeah. Yeah. Oh, look, now it looks an awful lot like the question we just did. Carry on. Yep. And we're done. Nope. You just got to apply it again and again and again and again and again. So we can do this though with all sorts of weird looking things. Take a look down at the bottom. There are 3 questions there that look a little weird. What would I do with something like 9 minus y squared? Is 9 a perfect square? Is y squared a perfect square? Am I subtracting? So I do exactly what I did before. Bracket, 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 bracket. What's the square root of 9? Yep. And we're done.
And then, okay, the next one. Should we distribute that?
Next one. Okay. X minus 6 squared minus 9. So there's a couple ways you could do this. Someone just asked, could I expand that thing and then see what happens? Yeah, you could. You could. Do you want to? There might be an easy way to deal with this. Is x minus 6 squared a perfect square? Yes, it is. What is the square root of x minus 6 squared? It's just x minus 6. So this thing's going to look like bracket, 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 bracket. X minus 6 plus 3 and x minus 6 minus 3. Because 9 is also a perfect square, so I have a difference of squares. Which means, what is my final answer? What is negative 6 plus 3? You betcha. That is my final answer. If you had chosen to expand this thing, it also would have given you the exact same answer. If you want to prove that to yourself, I will let you prove that to yourself. Oh, hold on. You're not how are we distributing this? What does it mean to distribute this? I just saw some hands that made me question myself. It's going to be x minus 6 times x minus 6 minus 9. And I'm going to then FOIL. You cannot just distribute that exponent inside. I saw it all over the exponents test I just marked. In fact, I even regularly remember giving you a lesson where I said, never do this, knowing a whole bunch of you are gonna, and then I saw it on the test. Do not distribute an exponent in there when there are multiple terms added and subtracted together. And what did I see happen? Exactly that. So if you distribute this thing, you're going to get x squared minus 6x minus 6x plus 36 minus 9, which means you're going to get x squared minus 12x plus 27. What numbers multiply to positive 27 and add to negative 12? Good. And we got the same answer, which is great because we.
But it took way longer.
Yep. Last one. Is it a difference? Are they perfect squares even though they look gross? So you do exactly the same thing. It doesn't matter what they look like. You still know how to treat them with respect, and so we're gonna. There's a application to other parts of life there. So what's this going to be? Who wants to give me our answer?
D plus 4 minus 3 minus 2 times.
And careful with this one. E minus 2 needs to be in brackets because you're subtracting all of E minus 2.
Oh, okay. And then times D plus 4 plus E minus 2. And then we can square root the 4.
One more time.
Wait, no.
No. What are we going to do now?
We can say the second question we could say D plus 2.
Yeah, because I just grouped the 4 and the negative 2 together. And then what's going to happen here?
Wait, but why are the other A minus 2? Why is it not in brackets?
Because does anything change when you add something?
Oh, okay.
It's because you're subtracting it here that you need to make sure you subtract everything there properly.
Okay.
Because it's not just minus E minus 2, it's minus E minus 2.
So we have just bracket D plus 4 or minus bracket E minus 2 bracket?
Yep.
Bracket.
Yeah.
Okay.
But the only bracket that matters is this one that goes along with the subtraction.
Right.
So then we're going to get D plus 4 minus E plus 2, which means we're going to get D plus 6 minus E and D plus 2 plus E. It looks gross, but every step along the way, you guys are fully equipped to do. Even though you don't like how it looks at the end, doesn't mean you can't do it. We are done.
What do you mean done?
The chapter's over. Welcome to the end of the chapter. Oh yeah. Yeah. No, for you or for me. Okay, so I want you to flip the page. I do not have any more specific questions on. Here's what we're gonna do. Okay. We're almost done. Let me finish real quick here. Actually, we're going to leave this page the way it is. We're going to jump to this page here. Flip to this page. And the instructions are factor each completely using all of the techniques that I have shown you over the last 3 days. GCF, simple trinomial factoring, and the other one, difference of squares. Okay? And I want you to do odds. And you're going to do odds up to question 30, and there's a bunch of questions here. Sorry, a bunch of answers here. Okay? This is as far as I'm going to get you to go. Do as much as you can on that tonight. It's 15 questions. Practice this stuff rather. Sorry? Is it? I have no idea. I have no windows and I don't know what's doing outside. I have no windows. You tell me if it's raining outside. Okay, that's what I want you to do. You do not pack up till you hear the bell. Give her. Begin. those are the instructions there. Using everything I have shown you. Yeah. Is it? Too simple. Don't bother me.
What are we doing
This
then?
one or this whole technique? Okay. Do not pack up. Pack up with the doggos. I don't care. You have enough time to do a bunch of questions. Yeah, we're by the door underneath the TV. I got my perfect squares. I got e plus 4 squared and e minus 2 squared. Because I got these. There you go. There's the bell. Now you make it a garbage can. Oh, garbage bag. Yes, behind Olivia in that cupboard there. Like knee height off the ground on the right. Carolyn, lower. Knee high. So, do practice this stuff, guys. I'll take up any questions tomorrow. And I'll see you then. What is that creepy looking thing you got there? Creepy. Dude has way too many teeth. Can you explain to me what's going on here? Yes, it's a devil, but there's a man on one side and a woman on the other side.
Basically it's equality.
I still don't understand.
So basically
Society.
So society is evil.
No, society is
Usually the more valuable things are lower down because they're heavier.
oh my god!
Oh my god.
No, because the woman has so much weight, like she has so much issues that she's dealing with, but she's heavy.
Oh, okay.
Gotcha.
Like I'm gonna write something like,
Gotcha. I am confused. Because maybe stuff's not done. It looks cool. I feel like there's going to be a weighty message. But I don't know what it is. I'll be here at 7:15. Perfect square, perfect square. So just like this one here. Simple one. The square root of x squared is x, so it is x and x. And then 1, 1. So this one's going to be I have b plus 4 squared. So I have b plus 4 and b plus 4. And I have b minus 2 squared. So I have b minus 2 and b minus 2. And then I add, subtract, b2. And then the rest is just simplify.
okay, so how do you?
So here, because this is all just addition, I just drop all the brackets, and then positive 4 minus 2 is 2, and then the b minus 2 is there. So b plus 2 plus b.
Oh, okay, super.
And then this one, to deal with the subtract, because I want to subtract this whole thing, I have to distribute this with a negative in there, so it's going to become minus b plus 2. See you later, Carolyn. Because subtraction is the only one that causes this group. Because it does like it's adding e. Because if I say we're going to add e minus 2, well, you're adding, you have to subtract 2. But if I tell you we're going to subtract e minus 2,
Yeah.
because e is positive and I tell you we're going to subtract it, it's going to be minus e plus subtract.
Right.
And if you have a negative 2 and I tell you you're subtracting a negative 2,
Right.
what you're going to do is adding 2.
Yeah. So I'm kind of understanding that.
When's the last time I saw you? Was it before spring break?
Yeah. Okay, I'll try and do that. Okay, this one.
Try. Using all our techniques, don't think there's any questions here tomorrow.
Okay.
How far along?
12 weeks. Tomorrow. Or Saturday.
Oh yeah, you have an award.
I did that.
How was it?
I won.
Yep, that's the thing.
Character service award. Better name it that. That's the one just the one last
Sorry. I better name it after you. What if it's a guy? Do you name Scarlet?
Scarlet Tio.
Or
Like a superhero name.
okay. Feel like that's not gonna fly. See you tomorrow, Danny.
That is so exciting. Congratulations.
Thank you. It's pretty exciting.
I actually hi. Oh girl, what's up? How about you? Good. Okay, good. I'm so excited to meet you.
Let's see it.
What do you mean?
Let me see your hand.
My hand? It's not my hand.
Oh.
I know, that's what everybody thought.
What's your news? I have exciting news. She's hiding her hands in her pockets. What am I gonna think?
They're not even, they're trinomials, and all you have to do is factor. They're just factor.
My baby.
You got a puppy.
I
And then
did.
brackets, exponents,
Nice.
A rescue. Her name is Luna.
What is Luna?
She is a Chihuahua Portuguese Pango.
I don't know what that last part is, but that's okay.
I don't know, but I know.
Portuguese
it's
Pango is a rabbit hunter.
Cool.
Yeah. She's now a therapy dog.
Okay.
Nice.
Cute.
Now I gotta ask, you're still seeing what's his face?
Yes.
Okay.
Yeah. But it's
Jesse.
my dog.
Nice.
My dog, not his. He wants to participate in it, put a ring on it.
Excellent.
Because if you can raise
This is not
a little
joint
furry
custody.
thing,
This is not a joint custody situation.
it is not. So, if you can commit to raising a little furry thing with me, you can put a ring on it.
Excellent. I like it.
That's all.
Sweet. No, it's cool. How's life?
It's good. It's good. Busy. I'm in school full time right now, so I'm
Good.
not working as much.
4 or 5? What's full time for you?
Um,
Because 4 is technically full time.
they've changed it to 3.
What?
3 is full time now.
Says who?
You have 3. Yeah, so I have,
Boo.
I'm in Kin 170, I'm in Stats 104,
3 is a full time course load now?
and Psych 101.
What?
Yeah.
Yo.
Question. So for the prize for short story contest, would it make sense for like an Indigo or like Kohl's, so like bookstore gift card? Because I feel like for people who do writing and reading, I feel like it would be a good thing, you know, to give them something so they can buy writing and reading stuff. And then that fits with the whole like 25 per person, or I could even trim it down a little bit. So does that work?
Make it 20 per person.
Okay.
If you're gonna go get the gift card route, yes.
Yeah, 'cause then that
Works for me.
Okay.
It makes a lot of sense. Don't forget your receipts. Make sure you bring me the receipts.
Yeah, just because I know you're like, don't do gift cards, do something different. But this case, it would work.
Well, a gift card, you can always find a gift card that works. I just want to push you guys to get more creative. But, you know, if you're going to go the gift card route, then 20 each is fine. Still don't want I'm done pushing, done fighting. I'm done leadership, so
How are you?
I'm done.
Last year?
Yep. I went down and told Mr. Sadu, I'm done. He's like, well, do you have someone in mind to teach you? I said, no, I'm just not doing it anymore. I said, well, who are we going to get? I'm like, that's a good question. You should figure that out.
I love that.
He's like, well, what if we give it to you? I'm like, I won't run a class. We just won't have a literature program. And you can call my bluff if you want. Oh, I was that
Yeah, I know, you would.
done.
Yeah.
So, especially with this one. I got 2 now.
Yeah.
I'm not coming early anymore. He's going to be up early anyway.
Yeah, no. I cannot imagine having a little one. Running around.
And Natasha's still doing great, so she's adorable.
Good.
I guess I could have shown you those pictures too.
Yes.
Here's Mother's Day. There's a whole bunch of pictures here for Mother's Day. Let's see all of them. Hold on. Make sure I actually downloaded them.
I cannot stay for too long. Because I
Okay, I'll
have to
be
see my
fast.
baby.
Be fast. Is she in the car?
No.
Or he in the car?
I
Is he
brought
in the
her
car?
here yesterday, actually, but I didn't come into the building
Ah.
because I wasn't sure. So, thought I should bring her tomorrow. See you on the weekend.
You gotta be careful what time you bring because we have a whole bunch of dogs now coming into the building.
I know. This is not fair. Why weren't they here when I was here?
No idea. The beast next door.
Beast next door.
His
Oh,
name's Winston.
yes, I met him.
Freaking love Winston.
Freaking cute.
So here is Mother's Day. That's my mom. Yeah, you can swipe. is pretty awesome.
I can't believe I suck at that card.
I can't quite either, but it's a thing. Oh, that's my sister.
Aww. I cannot get over her smile. And all of her teeth. How old is she?
16 months. 16 months.
Tomorrow. Friday.
It always depends on her naps. Every Friday, Core tries, but if the naps don't line up, then there's no way I'm pushing. It would be bad for everyone. Oh. Yeah,
Cute.
but Core tries to bring her every Friday. She didn't love going down head first on her back on the slide, but she loves the slide, and that's her trying to put on my mom's glasses.
Oh,
She's pretty great.
she's fantastic. Oh, she's so sweet. She's so beautiful.
She's a great little kiddo. So. And she just spontaneously did this on my sister's birthday.
Oh yeah?
She was just kind of climbing up on my sister, and then I kind of got it and swiped to the, progress the pictures. Keep going, keep going, keep going. And just that was the first time she'd gone in to give my sister a hug. Like, she does this sometimes, usually just to Cora and I. But she just recently started doing it to my mom and sister, where she'll just you're holding her, whatever, and she'll just go in for the hug. It's really adorable. Yeah.
Not for not now.
No,
Too much. But
no.
I like them when you can give them back.
Yeah.
Personally.
No, she's pretty great.
That's so exciting, number 2.
It's terrifying, but yes, it's exciting as well.
Are you guys gonna find out the gender?
Absolutely, we're gonna find out. Absolutely. So.
Did you find out at the end of June? Or
20 weeks, so 8 weeks from, you know, it actually might be, Core might have put it in the calendar already. Let's see if I can find her next ultrasound. No, Core hasn't put it. Oh! July 8th. Yeah, you'll be gone. You can always email me.
I will. I definitely will.
Yeah.
I'll write it on my calendar too. Email me up about the
We will always be done. We will always be. And that might not actually be the day we find out.
That's true.
It might not be. It depends on how they do it, because often they'll do the ultrasound and then they'll send the results to the doctor without telling you much.
Really?
Especially if there's something that's not going well.
Huh,
Um,
always.
And there are some places that won't tell you the sex, because there are certain cultural practices that encourage the termination of a pregnancy due to the gender of the child. So there are, I don't know how that
Because you're going to believe in that.
Huh?
Like the place you're gonna do ultrasound,
when we got with Natasha, I can't remember. It was COVID, so I didn't get to go to any of these appointments. I don't know if
This is
I get to go to a bunch of these.
So exciting!
So I got to see the heartbeat on our first ultrasound, so that was pretty wild. At 10 weeks, it's a little hard to give me.
I know.
But we will find out. So I don't know if they'll just give us the slip of paper, or if they'll send the results to the doctor, and the doctor then has to write it all down. I don't know
It's usually
what
a
the
doctor
procedure
has
is.
to sign off on the sex to determine whether it's correct or not, because
I don't.
the
So it might not even be that day.
the technician isn't actually allowed to give you that result. Yeah.
And
to have an MD.
our doctor knows that we don't particularly care what the sex of this child is going to be. So we're not going to terminate the pregnancy depending on whether it's a boy or a girl. So I can't see it being an issue. We found out the first time. We found out with Natasha. So we'll find out again.
Yeah.
I just don't know if it's that day or if it's whenever her appointment is, a couple days later or a week later.
Is the doctor here in Abbotsford?
Yeah. It's actually pretty funny. It's the maternity clinic off of
Oh, yeah.
Borkwin.
Yep.
kind of between Borquin and George Ferguson. It was an Abby Mac group. So we went in there, and we got our doctor assigned to us or whatever, and she was telling us about. She's like, oh yeah, my husband and I, we lived in Vancouver, and then we, went to Uganda for a while, and then we're back and we're doing this. I'm like, oh, that's interesting. And I know what her religious affiliation is. She's a Christian. And so I asked her, I'm like, well, you were in Africa. This is going to sound like a really random question, but, because it reminded me of something my cousin told me, because him and his wife went to Africa, and he's a teacher from Prince George, and they were working with, like, children of, like, medical professionals that were out there as a Canadian teacher.
Yeah.
Homeschooling them. So I'm like, hey, do you know, Keith and Carrie Workington? She's like, oh yeah, we met them in Vancouver and it was great. And we spent a lot of time with them in Africa. And my husband's from Prince George, so he's known Keith forever. So she oh yeah, like she's oh yeah, random, because they don't even live in Abbotsford. They live up in Prince George. They were in Vancouver. They were in Russia. They were in Africa. They're now in Prince George. So they were all over the place. And yeah, our maternity doctor.
Uganda to Africa to Prince George.
They went. He came from Prince George down to Abbotsford. She grew up in Abbotsford. They moved out to Vancouver when they were both doing school. Then they went to Russia. Then they came back to Vancouver, moved to Prince George, went out to Africa for a while, and then came back to Prince George.
But why would you want to end up in Prince George? Like,
That's where all his family is.
I live there, and it's not it. Like, it's not fun.
No.
And
Not
the
for
very
you.
cold heat is horrible.
They love it for their lifestyle. They're out. All his family is there. They love the snow. They're out in the wild all the time. They love it up in Prince George.
Okay.
Hike like crazy. I love northern BC. Northern BC, I think it's fantastic. I grew up there, going there every summer. Sorry? I don't know. You probably don't have reception here. But you gotta go, so. I'll be seeing you. The boys, plural.
Boy, sorry, the boy.
The boys, Scarlet.
Boys, not the boys.
Plural.
Have you seen All the Boys? It's on Amazon.
Oh, no.
You love it.
What's the boys?
The Boy. It's a superhero show.
Oh,
Where
aren't
they're
they
like-
all like
where they're
garbage?
assholes.
Yeah, no, I've looked at that. I'm like, no, I can't do it.
It's so
No.
good. Watch the first episode for me, please.
I don't know if I
Just
can
the
do it.
first one.
The stuff I've read about it is vile.
It's brutal. It's brutal,
vile.
but it's fantastic.
Violence I can handle. It's all the extra sexual crap that I don't need to deal with.
No, it's not like, okay, it's not.
It's disgusting from what I've heard. What I've read.
What's the show?
The boys.
Boys.
It's
It
like
is
these superheroes
so
that have turned
good.
bad.
Oh my god. Like, I love it. It's okay. They don't show. They don't show.
Oh, Maul.
I'm like, if I
Oh,
can
Maul.
watch it, it's fine.
No, that's not the case. That is no. What you choose to expose yourself to is not the bar by which I'm going to live my life.
Yeah, but like, it's really good.
Okay, I'll take it.
Really good.
I will take that under advisement.
Just watch the trailer on Amazon.
Oh, there's an apple in there.
Oh, there's a bunch of big names in it.
And it's from Toronto.
Oh, the guy from Gossip Girl.
A bunch of big names.
The guy, Nate from Gossip Girl.
Yes. Oh my god,
Yeah.
he's so good. I love him. I love him. He's definitely one of my favorites. He plays the character so well. He plays it so well.
What's the character's name? The Deep?
The Deep. Yeah. Oh. And then, oh my god, what's his name?
Don't know.
The blonde one. Played by Anthony Starr. He's basically like Captain America. Oh my god, what's his name? Homelander.
Homeland.
He is fantastic. He is so good. His character is vile, but oh my god, he does it so beautifully. So beautifully. Anyway.
We'll take your word for it. Good to see you, Scar.
I will try and come in tomorrow to see if the child
If she's here.
is here.
Did you go to this? I'm assuming you did.
Yes, yeah, I was a 2019 grad.
Everyone in she's a legend to everyone in leadership.
Am I?
I just joined last year, but like Mia.
So yeah,
and
she's
talking
new
about you,
was new to our building last year.
I didn't know I was that important.
There's every year there's a group that's legendary. Last year's group was Crystal
And Holly.
and Holly. The year before that was you.
I was surprised.
No, the year before that was Taylor and Sam and that crew. The year before that was you. The year before that was
No, you're really positive. Like last year they told me
Gellhorn.
a lot about somebody named Scarlett, and now I guess there's a face name.
This is the face. This is Scarlett.
So, yeah.
And before that was Sam and Chloe. Names that will live on, that have long since faded from people's memories, except for mine. Because they were,
Next year.
I personally think you are the best, but I
they
think
were.
biased.
Every year had a good crew. Was Chloe when you were in grade 9? Like Chloe Simjana, or were you in grade 11 with
I
them?
was grade 11 and they were grade 12.
With Chloe and Simjana and Sam Kish and
Yeah.
I don't even remember who else. Medea Khan.
They were 2018 grads.
Was Medea Khan in there?
I think so.
Because Medea was a rock star too.
Well, that was when
Benit was 2017.
Benit. That was that might have been my first year doing leadership. No.
That was the year that you and Shelby split up.
Right, and I had very little idea what was going on.
Exactly.
No idea what was going on. That was my first year here.
look at you now.
I have to go.
Now I'm
Nice.
bitter and aged. See you later.
I think we all did it. Wait, so this year it's gonna be like Mia, me, Brazil.
This year the group's a lot bigger.
There's like 10 of us.
There's this is the COVID grad class. You guys are all burnt out, not doing anything.
Yeah. Then what were Crystal and Holly?
Crystal and Holly were truly some of the best leadership students I've ever had.
I know they didn't burn out. Like they were doing the mental health
They
thing
were
in May,
unreal.
and I think we were burnt out. I think we're the burnout group of leadership.
You are the burnout crew.
We're the burnout group of leadership. 'Cause even a year ago.
You've all got stuff going on. Like
I mean, but so did they. I'm assuming they.
no, their burnout year was different. Like I remember sitting with Crystal while she sobbed. Her grade 11 year was when she had her mini breakdown. Holly never did. Crystal's was grade 11. There was a crew of grade 11s that just fried themselves. They were just so over involved.
Oh, I think so. I don't know if her name was Sophie or Sophia.
1 second.
I think she's next to me.
Hello, Steve. Oh, Sophia. I don't remember Sophia.
She played rugby. I think she went to Ontario, like Crystal did.
She was a leadership student.
She had like a stickers thing going on.
That was Crystal.
No, that was Sophia.
Sophia wasn't in leadership.
No, she was in leadership.
No, she wasn't.
No, she was. There was a Sophie or a Sophia in leadership last year.
I don't think so.
And I know this because when I joined, we were doing like a survey on like what should leadership do this year with like all of the restrictions.
Yeah.
And then nobody was
Sophia.
volunteering, so she volunteered. And I'm like, thanks.
Sophia.
God.
Who is Sophia?
I mean, I guess I could give you the skin colors, and you would remember maybe.
Oh! That was her first year in leadership.
Oh, really?
Yeah, I had never seen her before.
Really?
Yeah, I had never. Crystal, you're right. She came in right. Sophia, right. That's why I'm not remembering her. Because she was a rugby girl with Crystal, and Crystal just kind of dragged her into it. And she was hardly here.
Oh.
She was here probably just over half the time, so she missed so much time.
So she's like last year's Hannah and Mayher.
Yes, but more involved. Like Hannah. She's like Hannah. Last year's Hannah.
Okay.
Who, when she's here, still does stuff and is like, yeah, let's do stuff. But is only here like 3/4 or 2/3 of the time.
Right.
Right, Sophia. That's why I didn't remember her. 'Cause she was the first year. Yes, Sophia and Crystal.
What about Varsha? Was she also a first year?
Varsha was in it in grade 9,
Oh.
and not in grade. Was she in grade 10? She grade 9 with me for sure. I can't remember if she did 10 as well. She didn't do 11, but then she did 12. She was part of a crew of IB students who wanted it for their resumes and leadership and university applications.
Oh, that's why I joined too. Yeah. And it worked. I mean, I got accepted. I got money. It it worked out for me.
Doesn't mean leadership had anything to do with it, but
I mean, I guess so, but every time I fill out a scholarship application, they're like, what are you involved in? I'm like, I'm involved in leadership, and I've done this, and I've done that. But the weird thing about her is, like, she was graduating when I was in grade 9.
who?
Scarlett.
Yes.
Because she was a 2019 grad, and I was like, wow, that was 3 years ago.
Yep.
Now I'm graduating, and
Yep.
that makes me feel very weird.
Yep. And she still comes back and visits every 3 or 6 months.
What school did she go to?
She's at UFU.
You know what she's studying?
She studied a bunch of stuff.
Oh, okay.
I think she settled on kinesiology, but she jumped around. She was gonna go engineering at one time, then she was gonna go like plastic surgery at one time, and then she's like, I think she settled on kinesiology with like thoughts of becoming a physio. I'd have to ask her again, I don't remember. She's wanted to do so many things. She talked about going automotive, but her mom is a piece of work. Wouldn't sign off on it, so she couldn't do it. But she was top automotive student her grad year. Yeah. So yeah, no, she hung out with Wimmer and leadership. She was in my physics 12 class. That was the year of the cheaters in that physics 12 group.
Oh.
The one that I crushed them with the final exam.
Mhm.
She was in that class.
Did she also get crushed?
Nope, she got exactly the same grade on that. She was one of the ones that I always say, there was a couple students who got exactly the grade on the final exam that they were getting in the class going into the final exam. And she was one of them.
So if you had a 76 going into the exam, you got a
She got exactly, yeah. Her grade on the final exam was identical to her class grade.
So nothing changed.
Nothing changed.
Oh.
Her and a couple other ones. I asked a Tolentino, who you wouldn't know. They sat together and they both did as well on that thing as they were in the class. I asked her did better than Scarlett, but that was that class.
Oh. But something like that hasn't happened since then, right?
Not that I can tell. But yeah, no, 2019 doesn't seem that long ago. But
It's just for me, I don't know.
well, yeah, for you it's grade 8 to grade
Nine,
grade 9
12.
to grade 12. For me, it's it's the last 3 years of my life,
But hasn't that changed?
2 of which were COVID. It has, but not like yours has.
I mean, well, like,
I haven't changed.
you're like 34, right?
Yeah.
So when you were 31, you didn't have any kids, and you were just living your life.
But I haven't changed as dramatically as you have. My life has.
Like,
Things have happened to me.
personality-wise and, like,
No, like I was 31 to 34. Like that's.
no, but for me.
Oh, for you, you were a pain in the ass grade 9, and now
You
you're.
didn't have me in grade 9.
No, but I'm sure you were, because they all are. You were probably a.
I was slightly better. I like to think that I'm very mature for my age. Cause I
Well,
am.
probably you act like you are older,
Huh.
but you were in grade 9 once,
Okay. Fair enough. I just,
and even my best grade 9s don't compare to who they are when they're in grade 12.
fair enough. So, Mia in grade 9 doesn't compare to Mia in grade 12.
No, they're. Cause I mean, also, Mia's got a whole bunch of life experience now under her belt too. As she's told you, she's made some mistakes. And
Yeah.
so it's just there are certainly there are similarities in personality that go through, but you are radically different. Grade 9 you and 18-year-old you are radically different people. Even if you have some of those same personality traits, don't you agree?
Which one?
The difference. So, like we were just talking about how, like, the last 3 years, like for you and me, don't compare to the last 3 years of change for
Not at all.
these people.
Not
Like,
at all.
yes, you and I now have kids.
Yeah.
You and I are each 3 years older than we were, but I went from 31 to 34, and you went from what? 29,
27 to 30.
27 to 30?
Yeah.
And you've got a grad class that went from 14 to 18.
Yeah.
Like, that's just radically different than.
Yeah, we were already full and adult, and you guys went from kids to adults.
And you haven't changed a lot. Like, you now have a couple more kids, but as who you are, your
There's
personality.
still more gray hair.
But
and
as far,
more
yeah.
sleep deprivation, but
I have gray hair.
But for the,
you
but
just
largely,
drop it.
yeah.
I
You are.
am the same person, roughly.
I mean, there's always little things, but nothing,
Yeah.
nothing compared to what you guys have gone through over the last 4 years.
No.
All of this came from Scarlett walked in here. She was just visiting. Yeah.
There's so many of them coming back. Love it.
I've only seen a couple. Who else has come back?
I had a new come back.
Oh, I never taught a new.
I
had Blaine.
Nope.
He was like the same year as me with Christmas Carols.
That was only wasn't that only last year? Or was that 2 years ago? I had
2 years
Luke.
ago, I think.
I had Luke Pearson.
Yeah, Luke's that class. He was Blaine and them.
That was first
I
that was
had,
COVID spring.
I saw Mike didn't come back, but I ran into Mike.
Oh, I'm still recording.